Welcome and hi everyone. Today I will continue to our next subtopic, which is called Doppler Effect, and this is the learning outcome for this subtopic. A. Set Doppler effect for sound waves. And B. Apply Doppler effect equation. The equation is FO is equal to V plus minus VO over V plus minus Vs times Fs. And this equation is relative motion between source and observer, and it is limit only to stationary observer and moving source or vice versa. Okay class, for today's topic, first I would like to ask you a question. Have you ever heard a police car or an ambulance pass beside you and somehow did you notice that the sound of the siren changed suddenly, like this? Okay, one more time. Okay, what are you experiencing just now is called the Doppler effect. Okay, what is the Doppler effect? In 1842, an Australian physicist called by the name of J.C. Doppler had proposed the Doppler effect. According to him, the Doppler effect is a phenomenon observed whenever a source of waves is moving with respect to an observer. Or in the other words, Doppler effect refers to the change in observed frequency during the relative motion between a wave source and its observer. As you can see from the figure, let's say that you are standing and not moving on the side of the road. Suddenly, you heard the siren of an ambulance. At first, you heard the siren is in lower pitch. And as the ambulance approaches, the sound pitch is increasing to a higher pitch. Even though from the driver's perspective, the siren is playing the same pitch the entire time. So what happened is, okay, let me explain. First, the ambulance is away from you. So what happened to the sound wave is, the sound wave is spread out and you hear them at a lower frequency or a lower pitch. Because you have to remember this, the frequency of sound waves is pitch. Okay, next. As the ambulance coming towards you, the sound wave that is emitting from the ambulance is bunched up and so are delivered to you as a higher frequency, which you interpret as a higher pitch. Okay, next. For our first scenario, I would like to explain to you what happened when both source of sound and observer were in stationary condition. Okay class, you have to bear in mind that any source of sound will emit sound wave to all direction with the same speed, and therefore they produce a spherical wavefront. At first, we look at the source of sound, which could be an ambulance siren, a truck, or a train. The symbol for the source of sound is capital S here. And then we have the observer who heard the sound emitted by the source. The symbol we put here is capital O. As you can see from the figure, the movement of wave is towards the outside of the source. Same goes to the speed of sound, level V here. And lambda is the wavelength of sound wave. Fs is the source frequency, and Fo is the apparent frequency, the frequency that heard by the observer. And okay class, I would like to repeat again. Any source of sound emits sound wave to all directions with the same speed and produce spherical wavefront. Remember that? Okay, next. So this is the equation for Doppler effect. As you can see, we use this equation to find the frequency of the observer or FO. The equation that you have to memorize is FO is equal to V plus minus VO over V plus minus VS times Fs, where FO is the frequency of observer or apparent frequency, and also you can put as a FA. It's the same thing. Fs is the frequency of source. V is the speed of sound wave, which is 330 meter over second to the power of negative 2. VO is the speed of observer, and Vs is the speed of source. Okay, next. If you notice, there is a sign convention for velocity for both observer and source. I will explain to you in details. Okay, we have our source of sound here in red color and observer here in blue color. Firstly, we take a look on observer's point of view here in blue color. Please take note that in this case, source of sound is in stationary state. Okay, when the observers move towards the source, the value for observer velocity or VO will be positive. But if the observers move away from the source, if you see here to the left, the sign convention is negative VO. Okay class. Secondly, we look on source of sound point of view, the red color here. Please take note also the observer is in stationary state, okay? Okay, if the source moves toward to the observer, the sign for source velocity will be negative. On the other hand, if the source moves away from the observer, then the sign will be positive. Alright. Okay class, there are few notes that you should bear in mind. I will explain to you one by one. Okay, first, the wavelength of the sound waves. What is wavelength or lambda class? Okay, wavelength is the distance between two adjacent wavefronts. Okay, the symbol for wavelengths is lambda. Next. In such a case where the source and observer are stationary, we can conclude that FO is equal to Fs. Okay, and as we all know, the equation for frequency is equal to velocity over wavelength or lambda. Next point is wavefront. Wavefront is defined as a line or surface in the path of a wave motion on which the disturbances at every point have the same phase. Before this, we focus on what happened to the wave and frequency when both the sound source and observer is in stationary. In this slide, I would like to explain to you what happened when we have a moving source but stationary observer. Okay, first, any source of sound emits sound wave to all directions with the same speed and produce spherical wavefront. This is all of you have already know. And the thing is, Doppler effect is perhaps best explained visually. Okay, first, I would like to explain to you the symbol for this figure. S, capital S, this is our source of sound. And it could be a fire truck emitting sound or the train is passing by you. Okay, OF is observer in front. OB is observer at the back. Please make a correction here. OB is observer at the back. Okay, V is speed of sound. Vs is speed of source. You can see here because the source is moving to the right, so the velocity also move to the right. Lambda F is wavelength in front of a moving source. This is lambda F. And lambda B is the wavelength behind a moving source. T is time taken for the moving source. Okay, we see the Doppler effect happening when the thing that emitting waves moves. In the direction it's moving, the wavefront bunch up and behind it they spread out. You can see here lambda F is bunch up and lambda B is spread out. If our object or sound source is moving towards a stationary observer, these bunch up waves are observed at a higher frequency. And if object is moving away from a stationary observer, the waves are observed at lower frequency. So that is Doppler effect, my dear student. By now, I really hope that you understand the concept or the meaning of Doppler effect. Okay, lastly, we take a look at the applications of Doppler effect in sound waves. Okay, you can see here we have a case where approaching and moving away fire truck or ambulance. Okay, without seeing the truck, we can know whether the truck is approaching or moving away by hearing to the and your sound produced. While the truck approach, the pitch of the siren is relatively high. You can make a sound right now. But as the truck passes and move away, the pitch suddenly drops, and it's vanished from you by the time. Okay, I hope you will understand what is Doppler effect, and I will see you in our next topic or chapter. Bye bye, class.